Welcome to the deep dive. You've given us this incredible stack of sources on the absolute foundations of psychological science.
We have.
And our mission today is to give you a shortcut. We're going to explore the history, the hard biology, and some of the really counterintuitive research that defines psychology today.
And we're not just, listing facts. We're trying to trace how these ideas evolved, how early philosophical debates actually pushed us to map the physical brain.
And in doing that, they stumbled on some of the most surprising and high-impact findings in science.
Exactly.
So let's start at the very beginning. If you've ever seen a psychology textbook, you've seen that Greek letter, psi.
Right, psi. It's the symbol for the whole field. It comes from the Greek word psyche.
Which originally meant what? Something like breath or spirit.
Breath, spirit, soul, yeah. And when psychology was just getting started, William James, back in 1890, he defined it as the science of mental life.
The science of mental life. I mean, that sounds really poetic.
It does. But it also created a huge problem for the field.
How do you scientifically study a soul?
Precisely. Because right after James, you get thinkers like John B. Watson, who basically said, that's not science.
He was a behaviorist, right? All about what you can see and measure.
The pioneer of it. Mm-hmm. He argued that if we can't objectively observe it, it's not science. So for him, the goal of psychology was simple.
Prediction and control.
The prediction and control of behavior. It's this tension, internal experience versus observable action that really drove everything that came next.
Okay, so let's unpack that with the first huge academic fight. Structuralism versus functionalism. They sound kind of dry.
They do, but they're the bedrock. Structuralism, which was championed by Titchener over at Cornell, was basically about analysis.
Breaking the mind down into its parts.
Yes, like taking the mind, putting it on a lab bench, and trying to classify every single little element of conscious experience.
So if my mind is a cake, structuralism wants the list of ingredients. Flour, sugar, eggs.
That's a perfect way to put it. And they did this using rigorous introspection. They trained people to report on their experiences with incredible precision.
But then William James and the functionalists came along and said, what?
They said, I don't care about the list of ingredients. I want to know the purpose of the cake.
What's it for?
What is it for? Functionalism was all about the function of the mind, the usefulness of a behavior. It was very Darwinian. How does consciousness help us adapt and survive?
So he wasn't interested in static parts. He saw it all as a process, the famous stream of consciousness.
Exactly. That's his phrase. And, it's funny, that old structuralist idea of introspection, it never really died.
No.
Just evolved. Our sources point to a modern method called autoethnography.
Which is a fancy way of saying a kind of structured narrative introspection.
Right. And it's being used to study things like the psychological impact of being in prison. A researcher who'd actually served time used his own detailed journals to analyze that experience.
So they're applying the oldest psychological tool looking inward to a really modern and critical issue.
It's a direct lineage.
Okay, so from the philosophical to the physical, let's talk about the biological structures. Because it wasn't long before we knew different parts of the brain do different things.
Right. And we should probably just quickly map out the four main lobes.
Yeah, let's give them job descriptions, not just a list. So the frontal lobe, that's the CEO, right?
It's the CEO, it's the motor cortex, it handles higher level thinking, planning, personality.
Mm-hmm.
It's what makes you you.
Okay. Then the occipital lobe in the back. That one's easy.
That's the visual cortex. It's the movie screen where you process everything you see.
The parietal lobe is next. That's the somatosensory cortex.
Your body's sensor. It handles touch, pressure, pain, temperature. It tells you what your physical body is feeling in this exact moment.
And that leaves the temporal lobe.
The auditory cortex. It's interpreting sounds, music, and crucially, language.
So that's the main command center. But it needs a wiring system to run everything, especially the automatic stuff.
And that's the peripheral nervous system, the PNS. And it splits into two key parts.
First is the somatic system.
Right, which controls your skeletal muscles.
Yeah.
Any voluntary movement, that's the somatic system.
But the second one, the autonomic nervous system, or ANS, that's where the really primal stuff happens.
It is. The ANS is your body's background operating system. It runs all the involuntary processes, heart rate, breathing, digestion.
And inside the ANS, you have those two famous subsystems that everyone should know.
Absolutely. You have the accelerator and the brake.
The accelerator being?
The sympathetic nervous system. It controls the famous fight-or-flight response. When there's a threat, it floods your body with adrenaline, gets your heart pounding, it prepares you for action.
And the brake.
That's the parasympathetic nervous system. It's the cleanup crew. After the danger is gone, it brings your body back down to a normal resting state. Managing stress is really about learning how to use that brake.
Knowing how much of this is automatic makes this next finding so interesting. Let's talk about performance, specifically sports psychology.
Ah, yes. The external focus advantage.
This one really goes against what you'd think is common sense.
It really does.
Uh,
So research by Wolf and her colleagues shows pretty consistently that focusing your attention externally on the outcome of your action is way better than focusing internally on your own body mechanics.
Wait, hang on. So if I'm learning to, say, shoot a basketball, you're telling me I shouldn't be thinking about my elbow position or my wrist flick.
You're better off not to. The research suggests focusing on the rim or the flight of the ball. In one study, they used a paddle boat.
Okay.
The group told to focus internally on pushing their feet forward didn't learn as effectively as a group told to focus externally on pushing the pedal forward.
So by focusing on the tool, not the body part, you actually improve.
Yes, because you stop consciously interfering with your body's highly efficient automatic motor programs. You let your system figure it out.
The takeaway is literally get out of your own way. That's huge.
It's a game changer for coaching.
Okay, another amazing finding. This one is about the aging brain and how it deals with distraction.
This is fascinating work from the University of Toronto. They looked at visual attention, which is basically the brain's ability to filter out junk information you don't need.
And they found that this ability gets worse with age.
It diminishes, yeah. They found older adults, the average age was 77, had what they called a leaky attentional filter compared to younger adults who were around 22.
So they have a harder time ignoring irrelevant stuff in the background.
Much harder. But here's the ironic twist.
Go on.
Because they couldn't filter out the irrelevant information, they ended up having a better memory for it later.
You're kidding.
Not at all. In the experiment, they were shown overlapping images, like a face on top of a house, and told to only pay attention to the face.
And the older adults.
They had significantly better memory for the houses, the very thing they were told to ignore. Their leaky filter accidentally helped them encode more of the scene.
Wow. So a system's failure can become an unexpected strength. That's a perfect lead-in to the real-world impact psychology can have. Let's talk about Mamie Phipps-Clark.
We have to. Her work is a monumental example of research driving social change. She was one of the first African-American women to get a PhD in psychology from Columbia.
And she and her husband, Kenneth Clark, are famous for the doll tests.
Correct. These were a series of studies in the 1940s. They'd show young black children 2 dolls, identical except for their skin color, and ask them questions like, which doll is the nice doll?
And the results were heartbreaking.
They were. An overwhelming majority of the children preferred the white dolls and assigned the positive traits to them.
Which was clear, scientific proof of the psychological damage that segregation was inflicting on children's self-esteem.
It was undeniable. And this wasn't just an academic paper locked away in a library. This research was presented as key evidence in the landmark 1954 Supreme Court case, Brown versus Board of Education.
And it helped end legal segregation in American public schools. I mean, that's about as high impact as research can get.
It's a powerful reminder of why this all matters.
And it's why the field has to be so rigorous. You can't just rely on gut feelings or what gets called folk psychology.
No, because our intuition is wrong all the time. The whole scientific cycle, from observation to question to study to conclusion, is designed to correct for our biases.
Give us a classic example of where our common sense just fails us.
Catharsis is a great one.
Yeah.
The common idea that if you're angry, you should let it out, punch a pillow.
Right. Get it out of your system.
All the research shows the opposite. Venting your anger aggressively tends to increase feelings of anger. Our intuition is just flat out wrong.
So we need the scientific method to keep us honest, which brings up the philosopher Karl Popper and this idea of falsifiability.
Yes, this is a crucial line in the sand for science.
Yeah.
A claim is only scientific if it's falsifiable.
Meaning you have to be able to prove it wrong.
There has to be some observation you could make that would count as evidence against your claim. If nothing can ever prove you wrong, you're not doing science.
The classic example being ESP, right? Extrasensory perception.
Exactly. If someone claims they can read minds, but then says, oh, my powers don't work when skeptics are in the room, well,
the claim becomes impossible to test. If they succeed, they're psychic. If they fail, it's the skeptic's fault.
you've created an unfalsifiable loop. There's no way to be proven wrong, so it's outside of science.
But this pursuit of knowledge, this rigor, it's run into some profound ethical problems over the years. We have to talk about the dark side.
We do. And there's a deep conflict sometimes between the goal of gaining knowledge and the well-being of the people in the study.
Let's start with the Milgram shock study.
A famous and infamous experiment. Participants were deceived into believing they were delivering painful, even dangerous electric shocks to another person.
And the stress it caused was immense.
It was severe. Milgram's own notes describe people sweating, trembling, stuttering. Some even had uncontrollable seizures of nervous laughter. The debate still rages. Was the knowledge we gained about obedience worth the harm done to those people?
And then there's the Tuskegee syphilis study, which is on another level entirely.
It's one of the most catastrophic injustices in research history. For 40 years, from 1932 to 1972,
40 years.
the U.S. Public Health Service studied hundreds of poor African-American men who had syphilis. They were told they were being treated for bad blood.
But they weren't being treated at all.
They were actively denied treatment. Even after penicillin became the standard effective cure in the 1940s, the researchers withheld it, just to see how the disease would progress.
It's just a complete betrayal. It led to President Clinton issuing a formal apology decades later.
It did, and out of these terrible failures came our most important ethical principle today.
Informed consent.
Informed consent. Standard 8.02 in the APA Ethics Code. You must tell participants everything that might reasonably affect their decision to be in a study. The risks, the discomfort, everything.
Which Milgram and Tuskegee just completely violate.
In every conceivable way.
So we've gone from this philosophical split structuralism versus functionalism all the way to the physical wiring of the brain lobes in that fight-or-flight system.
And we've seen how systematic research can overturn common sense, like with the external focus advantage, but also how it has to be checked by a strong ethical code.
It's a field that has to constantly correct itself.
It absolutely is.
Which leaves us with a final provocative thought for you. Think about the research on the bystander effect.
The famous finding that the more people who witness an emergency, the less likely any one person is to help. It's called diffusion of responsibility.
Right. And this was confirmed in countless brilliant controlled lab studies by Darley and Latane. Hugely important work.
But the initial inspiration for all that research was the story of Kitty Genovese.
The woman who was supposedly murdered while 38 of her neighbors watched and did nothing. A story that became a national symbol of apathy.
Except we now know that story, the one about the 38 silent witnesses, was largely inaccurate. It was overblown, it was misreported by the media.
So here's the question for you to think about. We have a flawed, sensationalized anecdote, a piece of folk psychology, really, that spurred scientists to conduct perfect, rigorous research, which then confirmed a real and powerful psychological phenomenon.
Can a faulty observation sometimes be the spark that leads to an accurate, profound scientific truth? It suggests that sometimes even our mistakes can point us in the right direction.